Welcome back, grade 10 students. This is teacher Hazel and I will be your math teacher for today. Are you ready for our next lesson? At the end of this video, you will be able to find the terms of the arithmetic sequence using the arithmetic sequence formula. Are you ready? But before that, let us have some recall about arithmetic sequence. Now, what is an arithmetic sequence? Arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called a common difference. Now, what is a common difference? A common difference is a constant added to each term of an arithmetic sequence to obtain the next term. Now today, we will find the terms of the arithmetic sequence using the arithmetic sequence formula. Now the formula for arithmetic sequence is a sub n is equal to a sub 1 plus the quantity n minus 1 times d, where a sub n is the nth term, a sub 1 is our first term, a sub n is the term's location, and a sub d is the common difference. Let us apply the arithmetic sequence formula to our examples. We have example 1. Find the first 4 terms of the sequence whose first term is 5 and the common difference is 3. To solve this problem, we need to understand the problem first. Let us illustrate the problem. From our problem, it asks for the first 4 terms of the sequence, given that the first term is 5. Since the first term is 5, we can write a sub 1 is equal to 5. Given also that the common difference is 3. So from our problem, all we need to find is the second term, which is a sub 2, the third term, which is a sub 3, and the fourth term, which is a sub 4. Let us first find a sub 2. Since a sub 2 is on the second term, so our term's location is n is equal to 2. Now substitute the given values to our formula. We have a sub n is equal to a sub 1 plus the quantity n minus 1 times d becomes a sub 2 is equal to 5 plus the quantity 2 minus 1 times 3. Following the PEMDAS rule, we have a sub 2 is equal to 5 plus 1 times 3. We all know that 1 times 3 is also 3. So copy 5, we have 5 plus 3. We also know that the result of 5 plus 3 is equal to 8. Thus, our second term is 8. Now, substitute the value to our second term. We now have 5, 8. Now, let us proceed with our third term. Since our third term is a sub 3, we can write our term's location as n is equal to 3. Substitute the given values to our formula. We have a sub n is equal to 1 plus the quantity n minus 1 times d becomes a sub 3 is equal to 5 plus the quantity 3 minus 1 times 3. Following the PEMDAS rule, we have a sub 3 is equal to 5 plus 2 times 3. We know that 2 times 3 is equal to 6. Now copy 5. Now we have 5 plus 6. And we all know that 5 plus 6 is equal to 11. Thus, our third term or a sub 3 is equal to 11. Now, we can now substitute the value of a sub 3 to our sequence, which is 11. Now, our sequence becomes 5, 8, 11. Now, let us find for the fourth term, which is a sub 4. Since the fourth term is a sub 4, its term's location will be n is equal to 4. Now, substitute the given values to our formula. We have a sub n is equal to a sub 1 plus the quantity n minus 1 times d becomes a sub 4 is equal to 5 plus the quantity 4 minus 1 times 3. Following the PEMDAS rule, we have a sub 4 is equal to 5 plus 3 times 3. And 3 times 3 is 9. So copy 5. Our equation becomes a sub 4 is equal to 5 plus 9. And we all know that 5 plus 9 is 14. Thus, our fourth term is 14. We can now substitute the value of a sub 4 to our sequence. Now, our sequence is 5, 8, 11, and 14. Thus, our first four terms of the sequence is 5, 8, 11, and 14. Now, let us try another example. We have example 2, which is write an arithmetic sequence with 5 terms given that a sub 1 is equal to 4 and the common difference is 2. To solve this problem, we need to understand the problem first. Let us illustrate the problem. From our problem, it asks for the first 5 terms of the sequence, given that our first term, or a sub 1, is equal to 4. Given also that the common difference is 2. Now, since we already know what is our first term, which is a sub 1, let us find for the second term, which is a sub 2, the third term, which is a sub 3, the fourth term, which is a sub 4, and the fifth term, which is a sub 5. Now, let us start finding for the second term. Since the second term is a sub 2, then our term's location is n is equal to 2. Substitute these given values to our formula. We have a sub n is equal to 1 plus the quantity n minus 1 times d. We have a sub 2 is equal to 4 plus the quantity 2 minus 1 times 2. Following the PEMDAS rule, we have a sub 2 is equal to 4 plus 1 times 2. This results to a sub 2 is equal to 4 plus 2. Since we know that 4 plus 2 is just equal to 6, thus a sub 2 is equal to 6. Now we can substitute the value of a sub 2, which is 6, to our sequence, we have 4, 6, finding a sub 3, a sub 4, and a sub 5. Now let us find for a sub 3, which is on the third term. So we now have our term's location, which is n is equal to 3. Now, substitute the given values to our formula. We have a sub 3 is equal to 4 plus the quantity 3 minus 1 times 2. Following the FEMDAS rule, we have a sub 3 is equal to 4 plus 2 times 2. This results to a sub 3 is equal to 4 plus 4. And we know that 4 plus 4 is equal to 8. Thus, a sub 3 is equal to 8. And substituting the value of a sub 3 to our sequence becomes 4, 6, 8, finding a sub 4 and a sub 5. Now let us find for a sub 4. Since a sub 4 is on the fourth term, our term's location is n is equal to 4. Substituting the given values to our formula, we have a sub 4 is equal to 4 plus the quantity 4 minus 1 times 2. Following the FEMDAS rule, we have a sub 4 is equal to 4 plus 3 times 2. And we know that 3 times 2 is just equal to 6. Now, 4 plus 6 gives us 10. So, the value of a sub 4 is equal to 10. Since we already know the value of a sub 4, we can now substitute the value of a sub 4 to our sequence. We have 10. Now, our sequence becomes 4, 6, 8, 10, finding a sub 5. Since a sub 5 is on the fifth term, our term's location is n is equal to 5. Now, substitute the given values to our formula. We have a sub 5 is equal to 4 plus the quantity 5 minus 1 times 2. Following the FEMDAS rule gives us a sub 5 is equal to 4 plus 4 times 2. We know that 4 times 2 is 8, and 4 plus 8 gives us 12. Thus, our fifth or a sub 5 is equal to 12. Substitute the value of a sub 5 to our sequence. Our sequence becomes 4, 6, 8, 10, 12. Thus, our first 5 terms of the arithmetic sequence, given that a sub 1 is 4 and common difference of 2, our sequence is 4, 6, 8, 10, and 12. Now, do you have any questions? I would love to read your questions on the comment section below. Did you learn something? What have you learned? I would love to read what you have learned on the comment section below. To prove that you have learned something, let us have some activity entitled The Nth. Directions. Solve for the nth term of the following arithmetic sequence. Write your answers on your answer sheet. Are you ready? Then let's start! Solve for the nth term of the following arithmetic sequence. We have number 1, 3, 10, 17, 24, and so on. Find the 18th term or a sub 18. Number 2, we have 17, 14, 11, 8, 5, and so on. Find the 51st term, which is the term's location we have n is equal to 51. Number 3, we have a sub 1 equals 5, common difference of 4, and find for the 11th term which has a term's location of 11. Number 4, we have 3 5 halves, 2 3 halves, 1, and so on. Find for the 28th term. Number 5, we have 5, 7.5, 10, 12.5, 15. Now find for the 10th term or a sub 10. That's it. I hope you learned something. Thank you for watching, and I will see you on our next lesson.